Hey guys, welcome back to chapter 11. What we're going to do now is we are going to start getting a little bit more complicated. So we're going to start putting things other than hydrogen onto our carbon chains. And then we're going to start to explore this idea of double and triple bonds. So looking at alkenes and alkynes. So the first thing we're going to do is we're going to add things other than hydrogen to our carbon chains. When we add things other than hydrogen, we call those substituents. So atoms are groups of atoms that are attached to that carbon chain. There's going to be two types of things that we talk about being attached to that chain, or two types of substituents that we add. The first kind of substituent is going to be an alkyl group. So alkyl groups are just carbon branches that are attached to that longest chain. So I could attach again, still with the mouse here, so forgive me. I could attach a CH3 to the carbon chain. I could attach a CH2, CH3. Ooh, yuck. So I could attach different types of carbon branches to the longest chain, and that's called an alkyl group. And you'll know that with this YL ending when we start naming it. Okay. So here's some examples of alkyl groups. So again, that CH3 would be a methyl group. So where in the world did I get this methyl name? So it's one carbon, right? So if I add this to the longest chain, it's just one carbon. So there's our prefix meth. And because it's a substituent, because it's a branch that I'm adding, that's why it's going to get this ly ending, that eel ending. So if I add a single carbon branch, that's methyl. If I add a two carbon branch, that's ethyl. So again, eth for two carbons, YL because it's a branch. If I add three, that's propyl, so on and so forth. Okay, so that's the first type of substituent. The second type of substituent, or the second type of group that we're going to add to the carbon chain, is going to be what we call halo substituents. So halo substituents are adding a halogen to the chain. So replacing one of the hydrogens with a halogen. So here's our carbon chain, and it was hydrogen, 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 for example. And if I took one of those hydrogens off and I replaced it with a chlorine, for example, that would be a halo substituent. So I replaced it with a halogen, okay? Halo substituents are going to have those prefixes, right? Chlor, and then it's just going to add the O, and that goes with this O on the halo. So this would be a chloro group. If I put bromine, it would be bromo. Or if I put iodine, it would be iode. So it's just going to go with whatever we add, keep the prefix or the base name, and then add that O to the end. Okay. All right, so let's talk about how we name these chains now that they have substituents. So the first thing we're going to do is write the alkane name of the longest chain of carbons. So that's what we did before. If it's a 5-carbon chain, we write pentane. If it's an 8-carbon chain, we write octane. So that step is still the same. The next step is new. We're going to number the carbons. So here we can your instinct is going to be to number from left to right. But we want the substituent or the group that we added in there, we want it to be on the lowest number carbon. So there may be some cases, some examples where we count backwards. So we count from right to left. So we need to look at both scenarios for sure. And then we're just going to tell the viewer where each of the substituents or extra groups are on that chain. So that's why we number the carbons. So we can say on carbon number 2, there's a bromine. On carbon number 5, there's a methyl group. So that's why we number the carbons, so that we can give the viewer a map, give them where everything is. So here is the example that we're going to walk through together. So first things we need to identify is here's our carbon chain right here. There's our carbon chain right there. So that's our backbone of our structure right here. Okay. When we see something other than a hydrogen attached to this backbone, we need to highlight it, whether it's physically highlighting it or just highlighting it in our mind. So if I look at this carbon, hydrogen, 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 nothing to note. If I look at this carbon, hydrogen, oh, there's a chlorine. Let me highlight that. Let me register that. Go to the next carbon in my chain, hydrogen. Whoa, there's something crazy attached there. Let me highlight that. Next carbon, hydrogen, hydrogen. Next carbon, hydrogen, hydrogen, hydrogen. So nothing to report there. Okay. So that's one of the things that you're going to have to start registering is what's attached to the backbone other than hydrogen atoms. Okay. Now we need to number the carbons starting from the end nearer the substituent. So as I'm getting proficient at this, I like to just go ahead and name left to right, number left to right and right to left. That way I have both on the paper and I can do a better job of picking. So if I number left to right, which is going to be most of your instincts, this would be carbon 1, carbon 2, carbon 3, carbon 4, and carbon 5. And then if I number the other way, just to make sure that I hit everything, this would be carbon 1, 2, 3, 4, and 5. Okay. So we want our substituents to be on the lowest number carbons. We want them to be on closest to the start of the chain, to be closest to our substituents. So if I number the blue numbering system, number left to right here, I have a substituent on the second carbon and on the third carbon. So that would be a 2, 3. And if I use the red numbering system, I would have a substituent on the third carbon and on the fourth carbon. So that would be a 3, 4. Okay. So I'm going to pick the blue numbering system because that puts my substituents on 2 and 3. 2 and 3 are lower numbers than 3 and 4. So we're going to pick the blue number system. So let's clean this up a little bit. We don't want 3, 4, and we don't want these red numbers. And we got it. It was 2, 3. We got that. Okay. All right. So now we just need to draw a map in word form so the viewer knows exactly what this looks like. So you could start anywhere you want to start. I like to start with just the base chain here. So I got a 5 carbon chain, so I'm going to write pent. Okay. All of those carbon-carbon bonds are single bonds, so that's ane, A and E. Okay, so pentane. Now I need to give the location and the name of each of the substituents, and I'm going to do it in alphabetical order. So this is a chloral group. Okay, and this is a methyl group. Okay, so if I'm doing it in alphabetical order, C comes before M, so I'm going to put chloro down first. So I'm going to tell the viewer on the second carbon in the chain, there's a chloral group. Okay. And then on the third carbon in the chain, there's a methyl group. Still using the mouse, guys. Sorry, this is so messy. Okay. So the way that we would read the name of this molecule is 2-chloral, 3-methyl pentane. Okay. On the second carbon, there's a chlorine. On the third carbon, there's a methane. And then the chain is a total of 5 carbons long. So I'm step by step, I go through this. So write the name of the longest chain, number the carbons, and then give the location. Okay. So go ahead and pause the video and see if you can get the name of this guy. All right, so first thing to identify is our chain. So we start with simple ones. We start with these very straight chains. They start to get a little wonky later. So here's our chain, and it's got 4 carbons in it. So I'm going to go ahead and put A and E because it's all single bonds. And the prefix is butane. Okay. Next thing is I need to highlight, whether it's in my mind or physically highlight anything that's not a carbon, or excuse me, not a hydrogen. So hydrogen, bromine, carbon, hydrogen, bromine, carbon, hydrogen, methyl, hydrogen, carbon, nothing to report there. Okay. All right, so now that we've got our substituents highlighted, now we need to number. So we can either number 1, 2, 3, 4, or we can number 1, 2, 3, 4. If I use the red numbering system, my substituents are on 2, 3, 4. If I use the blue numbering system, my substituents are on 1, 2, 3. So again, we're going to use the blue numbering system, not because it's conventional, but just because our substituents are on the lower number of carbons. Okay. All right, so we numbered, we have our base. Now we need to tell the viewer where these substituents are. Again, these are bromose, that begins with B. This is methyl, that begins with M, so our B comes first. So I'm going to tell the viewer that on the first carbon, comma, and on the second carbon, there's a bromo. Okay. And then I got to tell them about this other one. On the third carbon, there's a methyl. Okay. So the way we would read this is 1, 2, bromo, 3, methyl, butane. The next thing I'm going to show you, you probably didn't write down, and that's okay because you've probably never done this before. But it's something that organic chemists do, I guess, to be redundant. I don't know. So the 1, 2 should make sense. So it's just a condensed way to say on the first carbon, there's a bromine. On the second carbon, there's also a bromine. But for whatever reason, they also like to put the prefix di. So that di just comes from the fact that there's 2 bromines. If I had 3 bromines in this structure, it would be 1, 2, 3 tri-bromo. So for whatever reason, they put the di there. I think it's redundant. If I have 2 numbers here, obviously I have 2 bromines, but they do it anyway. So Pearson, of course, is going to want you to put this di in. So it'd be 1, 2, di-bromo, 3-methylbutane. There you go. All right, for cycloalkanes, bad news is we still have to name cycloalkanes. Good news is we don't have to number them. So I'm not going to give you any examples that will have like 5 things sticking off where you have to tell me where everything is. That's just not going to happen. So don't worry about numbering for cycloalkanes. All you have to do is tell me what is attached to that that cyclic structure. Okay, so our base chain is going to be whatever the cyclic structure is. So this is, remember, cyclohexane because it's 6 carbon, and because it's all single bonds. So this is cyclohexane. And all I need to do is tell the viewer what is attached to cyclohexane. So this is a 2-carbon chain that I put on here. So that's going to be ethyl. So this is just ethyl cyclohexane. If there was a chlorine on there, you would just call it chloral cyclohexane. If there was a bromine on there, bromocyclohexane. So pretty straightforward. It's pretty easy. We got it. But if you need practice, look at these, pause the video, and there's your answer. Okay. All right, so we've named... looking at a picture, we've named the picture. We've added substituents, named the picture. Now we want to go the other way. So what if somebody gives you a map? How do you go about drawing the formula or the picture? So we're going to draw 3-bromo, 1-chloro-butane. When I draw them, so you'll find your own path as you get good at these, but when I draw them, I like to start from the back. So I like to go right to left. So the first thing I see here is that it's butane. It's a 4-carbon chain. So that's the first thing I'm going to write is a 4-carbon chain. So 1, 2, 3, 4. And there's my 4-carbon chain. Then I'm going to look at the things that are attached to that 4-carbon chain. So on the first carbon, there's a chlorine. So let me do that. Oops. So on the first carbon, there's a chlorine. If you want to draw yours facing down, that's fine. Whatever, it doesn't really matter. So on the first carbon, there's a chlorine. And on the third carbon, there's a bromine. So if you're saying that this is carbon number 1, 2, 3, that means there's a bromine on this one. And again, if you face it down, that's fine. Okay. So now we've taken care of everything that's in this map. Now we have to put in our hydrogens. So anywhere that carbon still needs to make a bond, we're going to put a hydrogen in. So looking at this first carbon, it's made 1, 2 bonds. So it's going to have 3 and 4. It's going to have 2 hydrogens because remember it wants to make 4 bonds. This carbon right here has 1, 2 bonds. So it's going to have 1, 2 hydrogens. This carbon already has 1, 2, 3 bonds, so I just need 1 hydrogen here. And this carbon has 1, 2, 3 hydrogens because it's got 1 bond here to that carbon. So to get all the points, you need to put the hydrogens in there. So whether you draw it as H2C and then put the Cl, that's fine. Or you explicitly draw them out, I don't care. but you need to acknowledge that hydrogens are in fact there, or else you will not get all the points. So that's where I'm going to end this video. Please go ahead and stop now and start working on alkanes before we get a little bit more complicated with alkenes and alkynes. Hope you guys found this helpful.